uses an IUPAC name. The IUPAC simply is an international body called the International Union of Pure and Applied Chemistry. That's not a test question, just if you're ever wondering what IUPAC means. But look at this name, 2,4-dimethylhexane. Looking at the end of that name, we see the name hexane. What does that tell us? It tells us we have a parent chain with how many carbons? 6. And because it's ANE, it's an alkane, those 6 carbons are connected with single bonds only. So if we want to draw this, I can start with a chain of 6 carbons. Now I've left some gaps in between them because I may have to fill in some hydrogens. But I don't want to fill them in until I've got everything else attached. The hydrogens in the parent chain I'll put in last. Right. So that's my 6-carbon chain. It says dimethyl. That means I've got 2 1-carbon side groups. Those are going to be CH3s. They're going to be attached to some of the carbons in my 6-carbon chain. The numbers tell me that the 2 CH3 groups belong on, one of them belongs on the 2nd carbon in my chain, the other one belongs in the 4th carbon. So if I number from left to right, I can put one on the 2nd carbon from the left and one on the 4th carbon from the left. I also could just as easily start numbering as carbon 1 as the one on the far right. I would have gotten the same substance ultimately. It may have looked slightly different, but ultimately it is the same substance. Now that I've got that, the last thing I do, I've got my 2 methyls in, I've got my basic connections in the hexane. Remember, carbon has 4 valence electrons, so for its octet it wants 4 bonds. It needs 4 more electrons. It does that by forming 4 bonds. What I'm going to do is I'm going to go through and look at how many bonds each carbon is already committed to. And for every additional bond it still needs of its 4 that it's supposed to have, I'm going to give it a hydrogen. So for example, carbon number 1, there's only 1 bond connecting to carbon number 2. So it needs 3 more bonds, so I'll give it 3 hydrogens. My 2nd carbon is already part of 3 different bonds. It's bonded to carbon 1, it's bonded to the methyl group, it's bonded to carbon 3. Since it already has 3 bonds, it only needs 1 hydrogen to finish up its 4 bonds. Carbon 3 has 2 bonds already, 1 to carbon 2, 1 to carbon 4, so I'll give it 2 hydrogens. Continuing that pattern. I get the final structure. Now, if you were looking at this molecule, you may have decided I want to number it from the right to the left. If I did that, how would that change the name? It would make it 3,5-dimethylhexane. And it would be wrong. Because we always choose the direction of the name, not on our personal preference, but on what gives us the lowest numbers. 2 and 4 is less than 3 and 5. So that would not be the preferred numbering system for this molecule. So take a look at these molecules. We're going to go ahead and take a look at them. We're going to work our way through the names. First, we're going to identify our parent chain, and we're going to name that. First one, what's the maximum number of carbons that you can see in a row? 5. Now, fall into the trap, although it works this time. Don't fall into the trap of just going straight across. That's 5 carbons. Make sure that if you started up or down or took twists and turns, you couldn't get more than 5. For example,